Okay, problem one. Alonzo and Rupert could go 105 miles downstream in the same time it took them to go 75 miles upstream. As soon as I start seeing words like downstream and upstream, I know it's a boat in the river problem. So the first thing I concern myself with is speed of boat in still water, speed of current. So it says the speed of their boat in still water was 18 miles per hour. So B is equal to 18 miles per hour. What was the speed of the current? Tells me I don't know that, so C equals question mark. That's the things I need to establish before I start drawing a rate time distance chart. And when I'm doing a boat in the river problem, the rate time distance chart is always going to have upstream and downstream as the categories. Okay, so rate is dependent upon both of these things. So going upstream against the current, I'm going to go slower than normal, so I take my speed of the boat in still water, subtract the current. Downstream or with the current is going to go faster, so I take the speed of the boat in still water and add the speed of the current. Okay, next thing I want to do is figure out times. It says in the same time. It doesn't tell me how much time either time is, so T equals. So in both cases they're equal to each other, but unknown, so T for both of those. And then distances, 105 miles downstream and 75 miles upstream. They actually give me the distances. They will do that in these problems. So no distance picture necessary because they're giving you exact distances. Fill out the entire chart. Again, speed of the boat in still water, speed of current, establish the rates. The times are going to be either the same or hour more, hour less, whatever they'll tell you. And they'll tell you the distances. Once you get everything in the chart filled out, rate times time equals distance, binomials, so distributive properties. So 18 times t is 18t, minus c times t is minus ct, is equal to distance 75. 18 plus c times t gets me 18t plus ct is equal to distance 105. So I got my system of equations here. And it's a elimination setup because the variable types are the same. The uglier variable is already set to eliminate, so we're ready to go immediately. So minus ct plus ct cancels, so I get 36t is equal to 180. Divide by 36, I get t equals 5 hours. Okay? That tells me how much time it took them in both legs. It asks me not only for the time, but also what the speed of the current was. So I know time is 5 for both. As far as getting the speed of the current is concerned, I know that 18 times 5 plus c times 5 is equal to 105. All I did was I took this equation, changed the t's into 5's. 18 times 5 is 90. It's positive 90, so it moves over to negative 90, so 5c is equal to 15. So c ends up equaling 3. So my answers are the current is 3 miles per hour, and the time is 5 hours. Answering both questions they asked me for. Moving on to number 2. Another boat in the river problem. Again, I see the words downstream and upstream. I know it's immediately that kind of problem. First thing I investigate are what are the speed of the boat in still water and what's the speed of the current. So, speed of the boat in still water, what was the speed of the boat in still water? We don't know that. What was the speed of the current? We don't know that. So we don't know either one of those things. So, B equals question mark and C equals question mark. These are the easiest ones to do on the boat in the river problems. So, I've got upstream and downstream again. I don't know either one, but B and C is what's representing those things. Going upstream, boat minus current. Going downstream, boat plus current. Notice I left myself a little bit of space here. You'll see why in a moment. Okay, they're going to tell me, if they don't tell me either of these things, they're going to tell me the times and the distances. So, downstream, 48 miles in 3 hours. So, 3 hours to go 48 miles. Upstream, 56 miles in 7 hours. So, 7 hours to go 56 miles. We know that rate times time equals distance. So, therefore, rate equals distance divided by time. Distance divided by time equals. So, 56 divided by 7 equals 8. 48 divided by 3 equals 16. And what we create here is within the chart, we have a nice little system of equations. A very easy system because b plus c and b minus c, the c's are going to cancel right off the bat. So 2 times b minus c plus c cancels. 8 plus 16 is 24. b equals 12. 12 plus c is equal to 16, so c equals 4. What was the speed of the boat in still water? 12 miles per hour. What was the speed of the current? 4 miles per hour. Okay, so expect the motorboat Alexis to go up downstream on the test. Again, we'll set up just like this. You'll get 2 nice easy answers. Moving on to number 3, the water in the Kern River flows at 9 kilometers per hour. Speedboat can go 24 kilometers upstream. Once again, there's upstream and downstream happening. So, speed of the boat equals something, speed of the current equals something. The current is 9 kilometers per hour. Water flows, that's current. How fast can the boat go in still water? Question mark. Okay, so again, I'm investigating the problem, trying to find this information. I know this, I don't know that, but again, that's what I need. I need to either know that I know it or know that I don't know it. I need to identify that. So, upstream, downstream. Upstream, boat minus current, that's boat we don't know, minus current 9. Downstream, boat plus current, that's boat we don't know, plus 9. Time. See, in the same time. So again, they don't tell us the time, but they're the same, so time. And we're going 24 kilometers upstream. We're going 96 kilometers downstream. So once again, it's a lot like the first one was. Binomial times time equals distance. So BT minus 9T is equal to 24. BT plus 9T is equal to 96. This time, unlike the first one, these are set to cancel, but that's the simpler object, one variable, multiple variables. So I want to change the signs. I want to take the top equation, negative BT plus 9T equals negative 24. So now instead of the T's cancel, the BT's cancel. Negative BT plus BT cancels. 9T plus 9T is 18T. Negative 24 plus 96 is 72. 72 divided by 18 is 4. So that's not what it's asking us for, but that helps us find what we're looking for. We're looking for B. I just figured out what T is. If I go back to this equation, change the T's to 4's. B times 4 is 4B. 9 times 4 is 36. Move the 36 over. We get 4B is equal to 60. We divide by 4. We get B is equal to 15 miles per hour. Sorry, kilometers per hour. So 3 types of boat in the river problems happening there. Find the current, find the time, find the speed of the boat, find the speed of the boat and the current. So just know all the scenarios. Again, the term containing more variables are the ones to get rid of with elimination. When you don't know the boat or the current, again, it creates the simplest system of equations. Number 4, graphing a system of inequalities. Job 1 is to graph the linear boundaries. If I take a look at this one here, y equals 1/3 x minus 2. Again, just imagine it as an equation. Y-intercept negative 2, slope 1/3. So y-intercept is negative 2, slope is positive 1/3, so up 1, right 3. And if I connect those, I'm going to connect that with a solid line because it says equals to. About like so. So that will be the first boundary line. The second boundary line has us graphing x equals 3. X equals number is a vertical line. This was going to be a dashed vertical line because it does not say equals to. So I'll get my line out here, get a dashed line at positive 3. We should have arrows on the end of that line, so let me fix that real quick. Alright, be careful. If it says y equals, it's going to be horizontal, x equals vertical. On homework, some of you are messing up on that part. So make sure you graph the boundary lines correctly. Either dashed if there's not an equals to, or solid if there is an equals to into the inequality. Next, we pick a test point. My test point I always pick is 0, 0. That's x equals 0, y equals 0. And all I'm going to do is take these two things and substitute them in for x and y in both inequalities to see if they make a true statement or not. If they're true, I shade towards. If they're not, I shade away. So for the blue line, if I put 0, 0 in place of x and y, I'm going to get 0 is greater than 0 minus 2. Don't worry about the equals 2 because it's not on the line, it won't be equal. Just worry about the greater than or less than part. So 0 here, times that makes 0 still. So 0 is greater than negative 2 is true. The blue line, the test point is true. So for the blue line, the test point is that direction from the blue line. So arrows up towards 0, 0. For the red line, if I'm putting 0, 0 in place of this, I'm only really putting x in because that's the only letter there. So 0 is less than 3. That's also true. So here's my red line. There's the point 0, 0. The truth is this direction. Putting it on either side of the other line. So everything that way of that line is true. Everything that way of the blue line is true. And what overlaps would be this region here. So the answer is the graph. It should be graphed as such. I'm looking for correct solid dashed lines for the boundaries, correct region shaded in for full credit. The only thing I get partial credit for is if you get the correct region shaded in but you have one of these solid or dashed wrong, you'll get half credit. If you have this shaded wrong, you're just going to be wrong. So I do need the correct shaded area, but again, if you get the dashing and solid lines not under control, then you get half credit for at least getting the correct region shaded. Number 5, a system of 3 equations. I got to pick a variable to get rid of. It doesn't matter which one I get rid of first. I'm going to choose z. I'm going to make this, let's go to the bottom equation. I'm going to change all the signs. So minus x plus 2y minus z equals minus 7. So now if I were to pair up the second and third equations, z minus z is going to cancel. So 3x minus x makes 2x. Negative y plus 2y is plus 1y. Z minus z cancels. 18 minus 7 is 11. If I pair up the top and the bottom equation, the z's are going to cancel. Negative x plus x also cancels. That's a bonus. If that happens, that just makes it easier. So x minus x, gone. Y plus 2y is 3y. Z minus z, gone. 10 minus 7 equals 3. 2x plus y equals 11, 3y equals 3. The easiest way to solve this is to realize that this equation tells me that y equals 1. Y equals 1 by substitution means 2x plus 1 equals 11. So 2x equals 10. So x equals 5. And once I know that what x and y equal, I go back to any one of the equations. I'm going to the top equation here. X equals 5 plus y equals 1 plus z equals something I don't know yet is equal to 10. So the top equation, x and y get replaced, z doesn't because we don't know it yet, equals 10. 5 plus 1 is 6, so z is equal to 4. Once we know all three answers, we put x first, y second, z last. If you want to make sure you're right, just put them all back into the original problem. You'll get true statements for all three. I'll just do the top one real quick just to verify. Sorry, the middle one. We already know the top one works. 3 times 5 is 15. Minus 1 plus 4. 14 plus 4 is 18. Bottom one. X equals 5. Minus 2 times 1 plus 4. 5 plus 4 is 9, minus 2 is 7. So it's real easy to check if you want to make sure you're right. Number 6, graphing a disjunction on a number line. First thing I want to do is deal with this inequality. I do not want to have a negated inequality. So x minus 3 and 2, negative 2 stay exactly as is. Not less than or equal to means greater than. That, if I solve, becomes x equals, or sorry, x is greater than 1. The other inequality, x plus 3 is less than or equal to 2. If I move the 3 over, it becomes x is less than or equal to negative 1. And again, the word or is between them. All that means is to graph this and this on the same number line based on that domain. So, I'm going to go negative 2, negative 1, 0, 1, 2, 3, 4. All right. So, if I start with the blue one, X is greater than 1. 1 is not greater than 1, but 2 is. We're dealing with integers. We're graphing only integers. No open circles are necessary on an integer graph. Greater than 1 goes on forever in that direction. X is less than or equal to -1. -1 equals -1. -2 is less, and that goes on forever in that direction. And again, the entire number line, both inequalities graphed on it, are going to be the answer. So that's what we get for the answer to that one. Number 7. Begin by extracting the complex fraction that's in the denominator. So 3 over 4 plus 5 over x. We're going to multiply times x times x times x to fix. That gets me 3x over 4x plus 5. The original problem then transformed from what it was into 1 over 2 plus. Instead of this box, I'm going to put in 3x over 4x plus 5. So job 1, fix. Reinsert fixed expression. Job 2 is to fix again. Now 4x plus 5 is the denominator. So 4x plus 5 times 2, 4x plus 5 times 1, and 4x plus 5 times 3x over 4x plus 5. On top, distributive property, 1 times 4x, 1 times 5 gets me 4x plus 5. For this term, 2 times 4x plus 5 makes 8x plus 10. And here, 4x plus 5 cancels 4x plus 5, so I get plus 3x. Final step, if like terms are present, you should deal with that. 4x and 5 obviously aren't like terms, but on the bottom, 8x and 3x makes 11x. So I would expect the answer to be there. Number 8, we have imaginary numbers in the denominator. That's illegal. So I'm going to multiply by the complex conjugate. All that means is I take the same two objects and change the middle sign to its opposite. 2i stays 2i, plus minus 3 becomes plus 3. I've got to multiply the top by the exact same thing. On top, I'm going to FOIL. So first times first, positive 3i times positive 2i makes positive 6i squared. Positive 3i times positive 3 makes positive 9i. Negative 2 times positive 2i makes negative 4i. Negative 2 times positive 3 makes negative 6. On the bottom, all I have to do is FL. First times first. Positive 2i times positive 2i makes positive 4i squared. Negative 3 times positive 3 makes negative 9. Once I've done all the multiplication on top and bottom, the I squareds are going to become real numbers. 6i squared is negative 6. 4i squared is negative 4. I squared is negative 1, so it just changes the sign of the coefficient and becomes real. And then we combine like terms on top. Negative 6 plus 6 is negative 12. 9i minus 4i is going to be positive 5i. On the bottom, minus 4 minus 9 make minus 13. And then having good complex number writing skills, I would then separate that into two terms. So negative 12 over negative 13 plus 5i over negative 13. If you want to write that prettier, that's positive 12 thirteenths minus 5 thirteenths I. Make sure the I looks like it's either right next to her or on the top. Make sure it doesn't look like it's on the bottom. I would not count this wrong, but I prefer to get to this point here. Number 9, solving a radical equation. The uglier radical is already isolated, so the first thing I would do is square the left and square the right. The left is a binomial squared, so I have to square the binomial the way I always do, which is square the first object, double the product, negative 4 squared to z doubled is negative 8 square root of z, and square the second. The squares are always positive, so positive z, positive 16, and then negative 4 squared to z doubled is negative 8 squared to z. On the right-hand side, squaring a radical just gets rid of the radical, so z minus 64 is what we get out of that. That successfully got rid of one radical. We still have another one left. I like my radical to be positive, so I'm going to move the 8 squared to z to the right. I'll move the z and the 64 over to the left. So minus z plus 64. These cancel, so I'm going to get 16 plus 64 is 80. Moving that to the right becomes positive 8 square root of z. Always get the square root isolated first, so divide both sides by 8, you get 10 equals the square root of z. And just like I did here, I squared both sides to get rid of a square root. I'm again in a square root situation, so I've got to square this, which means I have to square that. So I get 100 is equal to z. What that represents is the only number in the world that could possibly be the right answer to the problem. The last thing I have to do on a problem, anytime you have to square both sides, you have to verify the solution, make sure it actually works. So if I go back to the original problem, it says the square root of z minus 4 equals the square root of z minus 64. So z is 100, so that's 100 right there. That's 100 minus 64, which is 36. So both z's change to 100. Simplify. Square root of 100 is 10. Square root of 36 is 6. 6 equals 6 is true, so that's a good answer. I seldom, if ever, put one on the test that doesn't work out, so expect it to, but still verify. If this says something weird like 6 equals 2, throw that out, put the empty set. But again, I would not expect that to happen. Number 10, we're going to add vectors. Job 1 is to get rectangular form of our vectors. So I'll give a calculator out. To make rectangular form, I take the magnitude, cosine of the angle, magnitude, sine of angle. So the first vector, I'll circle it in blue here, is negative 2.46i minus 1.72j. The second vector, I type in 12 cosine negative 120 and 12 sine of negative 120. And that comes out to, circle this one in red, I'm getting a negative 6i and a negative 10.39j. So if I add the two vectors together then, negative 2.46 plus negative 6 makes negative 8.46i. Negative 1.72 minus 10.31 makes negative 12.11j. Right. So that's the answer in rectangular form. That answer gets you half credit. It's not that hard to do. Have that on your paper in case you mess up the rest of the process. Then we need to find the polar form. We've got to go back to polar form. R equals the square root of the two numbers squared and added together. When I'm squaring, I get positives anyway, so don't write minus signs in this step. So I type in square root of 8.46 squared plus 12.11 squared. I get 14.77. Step 2, the reference angle is the inverse tangent of the absolute value of the second over the first. So I type in inverse tangent of second divided by first. Again, that's absolute value, so no negatives necessary. So just if you write positives, just you can put parentheses instead of absolute value bars. 55.06 degrees. The final step is step 3. We have to establish a quadrant. So if you imagine graphing negative 8.46, negative 12.11, we've been down here somewhere in the third quadrant. In the third quadrant, theta is equal to 180 plus alpha. So 180 plus 55.06 makes 235.06. That magnitude with that angle is the answer. So 14.77 at an angle of 235.06 degrees. That gets you full credit. Again, this gets you half credit. Have it on your paper. If you try and do this and get it wrong, but you have the right answer in rectangular form on your paper, I'll still give you half credit for that. So kind of show your work like that. If your work looks like that, you'll get for sure half credit, because I can't imagine anybody typing things in a calculator wrong and adding wrong. So that's easy, but sometimes we mess up in this process. So make sure that shows up on your paper like that. Number 11. We're simplifying radicals of abstract objects. I'm going to have a raised dot like this, so it'll be very obvious what's what. So these are both 8th roots of these things and 5th roots of those things. I'm going to first of all modify, this is x to the 7/8 and this is y to the 6/8. Oops. And for this one, we're going to get times x to the 4/5 and y to the 3/5. Right? So that's job one. Get the radicals changed into fractional powers. Power divided by root, power divided by root, power divided by root, power divided by root on each base. Then for common bases we add powers. So for x I'm going to add 7/8 to 4/5. For y, 6/8 is the same as 3/4. You're welcome to reduce fractions. It makes the addition of fractions a little bit simpler if you do that. So for x the common denominator is 40. Times 5 makes 35, times 8 makes 32. For y, the common denominator is 20. Times 5 makes 15, times 4 makes 12. So the final answer is going to be x to the 67/40, y to the 27/20. And that's what I'm looking for, something along those lines. X to a fraction, y to a fraction power. Make sure the powers look like fractions. Don't put x to the 67. Make it look like a power. So when you write these things, powers are smaller and up a little bit. So make sure that it looks like a power. Don't make it look like a mixed number structure. Number 12. First thing I deal with when I'm looking at a problem of this variety where I have imaginary numbers to powers and I have radicals of negative powers is I deal with all the negative numbers inside of radicals. I don't like that. So 4i cubed is going to stay just as it is for right now. Minus 3 out of the 4 stays just as it is. Every negative in a radical becomes an I. So plus is plus. The negative makes an I. Square root of 16 is going to stay the square root of 16. Minus stays minus. Negative inside a radical makes an I. Negative inside a radical makes an I. These are being multiplied together, so these are being multiplied together. All right. Next, I deal with the radicals. If I can simplify them, I should. So this is going to stay 4i cubed for now, minus 3 out of the 4th for now. I'll deal with those in a moment. Square root of 16 is 4 being multiplied by I, so plus 4i. I times I makes I squared, and square root of 3 times square root of 3 makes 3. So square root of 3 times square root of 3 makes 3, still minus. I times I makes I squared. Okay? This sign's not affected by all the stuff I'm doing here. At this point, now I'm at a point where everything's either I to the first power, I to the second, third, fourth power. So I've got i's to powers. At this point, I need to deal with the i's. So I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is positive 1. I to the fifth goes back to I. So if I change all these to what they actually are, I cubed is negative I to the fourth is positive 1. I to the first is I to the first, and 3i squared, I squared is negative 1. So, negative I, positive 1, I, negative 1. And if I simplify those, I get negative 4i minus 3 plus 4i plus 3. And minus 3 plus 3 is 0. 4i minus 4i is 0, so the answer is 0. Probably be something other than 0 on the test. But at the point where you get here, you just add like terms. Real number first, imaginary number second. Number 13. Some of you are still struggling with this. I don't know how else to put it, so I'm going to try my best. Recognize numbers that have simplifiable radicals. So 8 is a simplifiable radical, 56 is also. I want each of these things simplified as much as possible before you start worrying about radicals in the denominator. So this first thing becomes 5 times the square root of 7 over the square root of 8. This becomes 3 times the square root of 8 over the square root of 7. And this is a minus the square root of 56. 56 is 2 times 2 times 2 times 7. You can go ahead and start breaking that down if you want to. But what I want to bring your attention to beyond that is the fact that 8 is 2 times 2 times 2. And so is this one. 7, of course, is prime, so I can't do anything to it. But 8 is composite, and it has a perfect square factor in it. So before I start worrying about this multiplied top and bottom by the square root of 8 that you might jump right to, this becomes 2 times the square root of 2. This becomes 6 times the square root of 2. So 5 times the square root of 7 over 2 times the square root of 2 is better than the square root of 8 on the bottom. Leave some space. 6 times the square root of 2 over the square root of 7 is better than 3 times the square root of 8 over the square root of 7. Leaving some space there. And then of course I can go ahead and take this 2 out, right? So 2 times the square root of 14. So that's fine. These still need to be fixed. Times the square root of 2 over the square root of 2 times the square root of 7 over the square root of 7. All you have to do is multiply by the radical thing. That fixes it. So this makes 5 times the square root of 14 on top. 2 times 2 makes 4. This makes 6 times the square root of 14 on top. Square root of 7 times square root of 7 is 7. And 2 times the square root of 14 over 1. What's left to do now is get a common denominator. The common denominator of 4 and 7 and 1 is 28. Times 7 times 7, so 35 square root of 14. Times 4, so plus 24 square root of 14. Times 28 times 28, so minus 56 square root of 14. 35 plus 24 is 59, minus 56 is 3. So that's our final solution. All right, number 14. So, negative 5x squared minus 2x equals 8. It doesn't specify a technique, so I'm going to use the quadratic formula. I like x squared positive when using the quadratic formula, and everything has to equal 0. So I'm going to move the 5x squared and the 2x over to the right-hand side. So we're leaving 0 on the left equals positive 5x squared because it moved, positive 2x because it moved, positive 8 because it didn't move. So therefore, a is equal to 5, b is equal to 2, and c is equal to 8. And once I know what a, b, and c equals, I'm trying to find out what x equals. We know it's going to have this structure. The three pieces are minus b, 2a, and b squared minus 4ac. So minus b is going to be negative 2. 2a is double a, so 5 times 2 is 10. And then b squared minus 4ac is just going to be 2 squared, which is 4, minus 4 times 5 times 8. That's 4 minus 160. 20 times 8 is 160, so negative 156. Okay. What's left to do then is to simplify that as much as possible, and I expect you to simplify as much as possible. So I'm going to, first off, that's a negative 156, I'm going to make it positive by putting an I out front. The second thing is, again, recognition of perfect square factors. I don't know what the factor form of 156 is, but I know 4 goes into it. So if I break down 156 over here, let's try 4 times 39. 4 is 2 times 2, 39 is 3 times 13. So 156 is that, 2 times 2 times 3 times 13, which is, if I pull a 2 out, 2 times the square root of 39. Okay, that's, again, it's basic, simple math there. I expect you guys to be able to do that. So x equals negative 2 plus or minus 2i times the square root of 39 over 10. Then the last thing I expect to do, since it's imaginary, is separate the answers and reduce fractions. So I'm going to get negative 1/5 plus or minus the square root of 39 over 5i. That's what I expect the answer to look like on that. So again, pulling an I out is easy. Simplifying square root of 156 down to that's easy. Reducing fractions easy. I expect you not to stop here, but actually get all the way down to there on these problems. Number 15, find x. The relationship between two intersecting chords in a circle is the product of these two pieces of this chord is equal to the product of the two pieces of the other chord. So it's supposed to be blue. So that product equals that product. So that means 3x equals 36. If we divide both sides by 3, I get x equals 12. The difficulty of that problem is just remembering the rule. It'll be the same rule on the test, so study. You'll be able to do it.